Do you all remember the cable car transition? It brings you from Route 112 to Mount Chimney, and while you're on the cable car the weather changes between sunny to volcanic ash, and there's even a slight chance you spot an NPC walking below as well, which doesn't really work as intended. Today we will talk about how all of this is coded and the coding errors that were made by the developers. Let's get started. It all starts at this building, which becomes available after confronting the grunts at Meteor Falls. Inside you can talk to the attendant, which will ask, "The cable car is ready to go up. Would you like to be on it?" If you agree, and of course you would, the player will follow the attendant to the cable car and gets in. Now before we get to the transition, we will talk about some code that happens here. First, there's a counter that is incremented that holds the value of the amount of times you've ridden the cable car. This is a value that can be used by the old man in Mauville City in one of his stories. Lastly, the war point is set to the other cable car location, so that we will arrive there once the transition is complete. After all of that, the fun begins and the cable car sequence is started. It's a nice day for a cable car ride. Just look at the beautiful blue sky and the mountains and the ashes from the volcano. But how do these different backgrounds and graphics work? Well, let's talk about them. The background itself is made out of 4 different layers stacked upon each other. We have the mountains and the sky in the back, the trees in front of that, the ground below the cable car, and these things. No, but seriously, what are they supposed to be? It makes a lot of sense for them to be pylons to support the cable car structure, mostly because of the sprites here in the overworld. But it honestly looks more like a lamppost to light the way for the people that walk here. What do you think they look like? Be sure to let me know in the comments down below. For now though, let's move on to the sprites. The sprites are drawn in such a way to make it look like the player is inside the cable car and moving upwards. The wire that the cable car moves along onto is made out of 9 small wire sprites to make it seem like one big wire. And like that, all the different sprites and backgrounds are initialized. Except for our little friends that walk down here, but we'll talk about them later. I first want to touch on the animation of the backgrounds and the sprites. As you move up or down the mountain, you can see the different backgrounds slowly moving across the screen as the cable car sprite moves along the wire. The background with the mountains and the sky doesn't move and is the only one that stays in place. Next up is the background with the trees, and this one moves diagonally every 8 frames by 1 pixel. The pylons in the foreground also move diagonally, but significantly faster. They move horizontally 1 pixel every frame, and every 2 frames it moves 1 pixel vertically as well. Once the pylons have reached the end, it needs to be reset properly to make it appear again. Lastly, we have the ground moving below us as well. It moves again 1 pixel every frame horizontally, and every 4 frames vertically. Another thing to note is that the ground in total consists of 3 different segments that all connect to the next segment in line. Like this, it looks like it's one big background when in reality we see the same segments appearing and disappearing. To animate this, it's a little more trickier than the rest. We know it moves at a speed of 1 pixel per frame horizontally and 1 pixel per frame vertically. But as we just discussed, we have to make parts of the background appear and disappear off screen to make it all look seamless. This is done by splitting each segment into smaller parts that are 16 pixels wide. Every 16 frames we then draw the next segment ready to appear again and make the segment that just went off screen disappear. This process keeps going like this until we have looped through all parts of a segment, because once that is done we have to buffer the next segment of the ground to make sure the ground always loops seamlessly. And like that, the ground below the cable car is animated. Lastly, in the animation department we have the sprites. They are animated in an interesting way. They use this formula to calculate the changing X and Y position of the sprite. The timer that is used in the formula is something that is incremented every frame. Like this we can calculate how they move across the screen. One last thing to note about the player sprite is that it bounces up and down. This is simply done by changing the Y position by 1 pixel every 11 frames. Now before we get to our NPC walking below, I want to talk a bit about the changing weather. When you start in Route 112, it starts out sunny, but after 350 frames, or around 6 seconds, the weather will slowly change to volcanic ash. As you can see, the volcanic ash moves towards us when traveling up the mountain in the cable car. This is done by changing the ash sprites to the right every frame. Now it's finally time to take a look at the coding errors that were made with the NPC walking below. This NPC doesn't walk here all the time and has a chance of 1 in 64 of appearing. In this list of the code here we can see that 4 NPCs are listed here. A hiker, a picnicker, a camper, and a Puchena or a Zigzagoon depending on which game you're playing. But no matter how many times you will ride the cable car up or down, you will never find the Buchanan or Zigzagoon appearing. But why? I'll let you take a look at this code and I'll let you try to figure it out yourself before I give the answer. Be sure to leave a comment with what you think the answer should be for this. Are you ready? Here we go. Now if your answer was just getting rid of the -1 here, so we have random value modulo 4, then congratulations! You've made it so that only the hiker will appear. And that is because of this statement right here. To get to choosing which NPC will walk up or down the mountain, the random value modulo 64 needs to be equal to 0. Modulo means what is left over after the vision. So in order to get past this initial statement, the random value needs to be a multiple of 64. If we then also do a modulo 4 on the same value, then it will always be 0 as well, because 64 is a multiple of 4. So this means if you get rid of the -1, it will only make the hiker appear. The person who initially coded this probably also noticed that the hiker is only appearing and added the -1 to it, thinking that would fix things. But this again will make sure that we will exclude poor Buchanan and Zigzagoon. This exact same coding error applies for deciding if the NPC needs to walk up or down the mountain, because 64 is also a multiple of 2. And also for choosing a delay for when the NPC should appear, because again 64 is a multiple of 4. So in the base game the NPC will always start at a delay of 0 and will always move in the opposite direction than you. I doubt that this was how it was intended. The question now is, how do we fix these issues? Well, let's say that we want to keep the chance of 1 in 64 to get an NPC to appear. We now have two options to fix it. One simple fix is to make an RNG call every time we need to do a modulo operation. This would mean that we have to make 3 more RNG calls. I personally have a different second option to fix it, and that is to get creative with the random value. We know that if we get to choosing the NPC, the random value is a multiple of 64. This means that if we would divide the value by 64, we have a new random value that we can use to choose which NPC will walk up or down the mountain. And instead of the vision, we will achieve this by bit shifting to the right 7 times. With this, the choosing of the NPC will go without problems and we can have all of them appear. We do a similar bit shifting for choosing the direction and the delay of the NPC, so that everything works as intended. And with that, all coding errors related to this NPC are fixed for this transition. After the transition has finished, you return back to the overworld and you're forced out of the cable car, ready to continue your adventure. I want to thank you all for watching, and I'll see you in the next one.